As a kid, I used to stare at the sky and ask myself, out of all those stars, all those worlds out there, is there another Earth? Last month, Codédex released their February monthly challenge, where we had to ask a question about something we love and then find a dataset that we can analyze to find the answer. And if you don't know about Codédex, then you're really missing on something. Codédex is a coding learning platform, but not your typical one. It's built around community, challenges, and actually building things. It's actually where I learned to code and honestly where my whole journey as a software engineer started. So I looked on the internet and that's where I found it. NASA Exoplanet Archive. A dataset of almost 40,000 records for over 6,000 confirmed exoplanets. 6,000 chances at finding a new home. So I built what I call the Great Elimination. It's a series of filters based on the Goldilocks search and what actually makes a planet habitable. First, is it rocky? Gas giants are out. Only planets between 0.5 to 1.6 times Earth radius survive. Then, is the temperature right? Liquid water needs a very specific range. Most planets are either scorching or completely frozen. And then, only stars similar to our sun can provide the long-term condition life might need. Do you remember? Over 6,000 planets. And after all that, we are left with 2. That's 0.03%. Kepler-452b, Kepler-62f, both found by the Kepler telescope, both orbiting sun-like stars, both sitting in the Goldilocks zone. So it made me realize something. We're not just rare, we're almost statistically impossible. But there is something more interesting. I didn't want to just trust my own filters, so I trained a machine learning model, a random forest, 200 decision trees, 9 planetary properties with 0 astronomy knowledge. And it found the exact same 2 planets. There was 0 disagreement between human intuition and the machine logic. But then the model revealed something I didn't expect. Some of the planets that I eliminated before, they actually scored higher on Earth similarity than the ones that passed. So my filters were too rigid and better candidates were hiding into the rejected pile. There is a reason for that. There is actually one last filter, and it's one that makes coming back to the project really interesting. Is there actually data? This project started as a data visualization challenge, but somewhere along the way, it became something else. Because when you stare at 6,000 words and watch them disappear one by one, you realize something. Everything we've ever known, everyone we've ever loved, every war ever fought, every dream ever dreamed, happened on the one word that passed the filter. So maybe there's another one out there. Maybe there's a slimmer hope for humanity to outlast the solar system. Or maybe not. If you want to explore the data yourself, the fully interactive website in the Calgary notebook will be in the link below. So go find your own answer. And if you're into space, physics, and the kind of software that asks big questions, then I'll see you in the next one. I'm Alan, and welcome to my channel.